The next major robot market may not be inside a factory. It may be the city itself.
For years, robots were basically locked away in highly controlled environments, right? We're talking assembly lines, massive warehouses, and fenced-off industrial sites. But that boundary is completely starting to disappear. Today, delivery robots are cruising along our sidewalks. Patrol robots are monitoring public spaces, and firefighting robots are entering areas that are just way too dangerous for people. You see, this is so much more than just a change of location. It is a fundamental change in what a robot business must actually become.
To actually survive out here, city robots have to navigate human environments. And just think about the stark contrast for a second. A factory floor is completely predictable. But a city? Well, a city is anything but.
I mean, sidewalks are incredibly crowded. Roads are uneven. The weather can literally change in an instant. You've got people, bicycles, cars, stray animals, stairs, and temporary construction obstacles appearing totally out of nowhere. A robot that works absolutely perfectly in a controlled lab might completely fail on a rainy, bustling street. So real urban mobility requires incredibly reliable sensing, safe navigation, and the intelligence to either stop or recover the second conditions change. And because they can actually navigate these wild, unpredictable spaces, robots are rapidly becoming a real part of our public services. For example, over in Singapore, autonomous patrol robots are acting as tireless, extra eyes on the ground, streaming live video feeds to authorities. And in Korea, they're developing these advanced patrol units specifically designed to detect fires, abnormal sounds, overheating equipment, and all sorts of hidden safety risks. We're also seeing delivery robots move out of those early controlled campus trials and straight into busy commercial districts and residential neighborhoods. And the absolutely crucial takeaway here is this. The true value isn't simply that a machine can move around. The real value is that it can perform a repeatable, reliable public service. Now, this utility becomes even more critical when robots enter environments that are inherently dangerous. Take the Los Angeles Fire Department, for instance. They operate the Thermite RS-3. It's this remotely controlled firefighting vehicle designed to pump out massive volumes of water while keeping human firefighters safely out of harm's way. And similar tech is currently being tested right now for collapsed buildings, hazardous material spills, industrial accidents, and really complex search and rescue operations. In these high-stakes, life-or-death situations, the robot is not replacing a firefighter or an emergency responder. It is extending their reach. But here is where it gets really interesting. As they move through the city, these machines are doing so much more than just their assigned physical tasks. Every single city robot is essentially a moving sensor platform. A patrol robot is constantly collecting visual, thermal, gas, and environmental data. Meanwhile, a delivery robot is mapping out exactly which routes are blocked, where street crossings are tricky, and exactly how the weather is affecting ground-level movement. Over time, all of this rich operational data drastically improves urban maps, maintenance schedules, safety planning, and overall service design. The robot is continuously updating the city's understanding of itself. But, of course, this immense data gathering creates a really heavy new responsibility. Cities urgently have to decide what data is collected, where it's securely stored, who gets access to it, and exactly how citizen privacy is going to be protected. Because of all this sheer complexity, the real competition in this industry, it's not going to be hardware. It's going to be operations. Let's be real. A city doesn't need a flashy robot that performs flawlessly for just one cool demonstration. It needs a service that works, without fail, every single day. And that kind of daily reliability requires an entire urban operating stock. We're talking charging systems, fleet control, remote intervention, maintenance, cybersecurity, incident response, and, frankly, clear legal responsibility for when something inevitably goes wrong. So when companies like Starship Technologies announce they've completed over 9 million deliveries, the most important lesson there isn't actually the number of robots they built. It's the massive operating network behind them. The monitoring, the regulatory approvals, the route data, and that continuous 24/7 customer support. Ultimately, standards in public procurement are going to be what decides which of these technologies actually scale up. Emergency agencies require measurable performance when it comes to mobility, endurance, sensing, and reliability. And cities? Well, they demand rigorous safety validation, strict operating rules, and crystal-clear procurement criteria before any of these exciting pilot projects can ever become permanent, funded services. This is exactly why the next robot race won't be won by hardware alone. The true winners will be the ones who successfully connect these machines with city data, control centers, safety standards, and public service contracts. A robot is a machine. A continuously operated robot network is city infrastructure. As these technologies roll out into our streets, our airports, parks, markets, and emergency sites, the entire landscape of urban life is going to permanently shift. The winners will not simply build robots. They will build integrated urban service systems.
This explainer has been brought to you by eXGateAI, your scale engine for global business, trade regulation, and market tracking. As we watch standalone machines evolve into vital city infrastructure, we really have to ask ourselves, when our cities are run by integrated robot networks, who is really in the driver's seat? Thanks so much for joining us.